All right, in this lesson, we're going to take just a few minutes to talk about some general guidelines concerning particle size and particle count. All right, so one of the questions that comes about pretty frequently from users is the question of what is the best method to actually simulate a good ice particle result as far as the rendered result? Is it best to use a smaller number of large particles, or is it better to use a higher number of small particles? And really, the answer is that it really depends on your particular situation. There really is no clear-cut answer to that. But there are a few general guidelines that you can sort of keep in mind that can really kind of help you make the decision. So in my case, I'm pretty much using the same particle simulation that we've been working with up to this point. And you can see that what I have right now is really a higher number of small particles. So you will notice that as we start to play this back that we have some nice movement in the particles from this wind, a lot of intricacy as far as the movement to these particles. So anytime I'm trying to simulate something that requires this kind of intricacy in the movement and in the flow, typically I find it to be a better use for these higher number of small particles. Also, whenever trying to create something that is maybe a little bit higher density or maybe the appearance of some kind of a thick volume, again, I find that using a higher number of small particles tends to do the job really, really well. You'll notice that as we start to play this back that we get pretty much the silhouette of this smoke broken up by a lot of these individual particles that sort of protrude out. So as we start to render this, these kind of shapes can start to come through in the shape of the rendered volume. Right, so again, we can start to get sort of these nice intricate results in both the simulation of these particles, so we should, whenever we render this out, start to see some nice movement of these individual particles. Plus, like I said, we get some nice breaking up of this silhouette by some of these particles that sort of protrude out. So if you're trying to simulate something that is a little bit thicker, a little bit more intricate, this is a good way to do that. The other option that you have is to try to use a smaller number of large particles, and that has its merits too. So let's take a look at just what this is going to give us. So let's start by going into the ice tree, just Alt-9 on your keyboard. And let's go into this modify particle size, because this is what's controlling the particle size of this particular simulation that we had set up. And I'll just simply take this multiplier and let's bump this up. Maybe to something like 2 or 3. So that gives us these really, really large particles. Now, because we have such large particles giving us such a wide area of coverage, we really don't need anywhere near the number of particles in this simulation. So again, let's go back to the ice tree. Let's go into this emit from surface node and take the rate down to maybe something like 20 or 30. All right, let's rewind this, play it back. You can see a much fewer number of particles, but because of the size, we get this really nice overall coverage. Now, this should give us something that maybe has a little bit smaller density or a little bit more of a kind of a transparent appearance, kind of a wispy smoke appearance. All right, so you can see it's going through. And if you're following along, one of the interesting things that you'll see is that even though we've dropped our particle count way, way down, our render time really has not improved that dramatically. So what I find is really kind of as a general rule of thumb, your render times really are not quite as impacted by the number of particles as they are by the complexity of this shape that we're trying to punch out of the overall volume. So something to keep in mind that lowering your overall particle count may not have just a tremendous impact on your render time if that is something that you're really, really concerned about. But you can see that looking at this result, we now have something that really doesn't appear to be quite as dense. We have these really long strands of texture, and this is being caused by the actual scalar fractal that we have plugged into the density. But because we really don't have as many particles as we start to get over to the edges, you can start to see a pretty high level of fall off as far as the overall opacity. And really, as we start to play this back, you can see that as far as the overall intricacy of the movement, we really don't have that nearly at the level that we had before, because we have a much fewer number of particles and there's really not just as much movement. So like I said, if you really are not terribly concerned about having any kind of an intricate movement, and if you want to try to get something that is maybe a little bit more like a soft cloud or a nebula, maybe using a a fewer number of large particles would be a better solution for your particular situation. So if we need to, once we bump up this particle size, we may need to go back into the render tree. So press 7 on my keyboard, and in my case I do have this fractal scaler plugged into the density of my particle renderer. So it might be necessary to come back and now start to adjust this size. Remember from the previous lesson we talked about that the overall size of your particles is very, very heavily impacted by the overall texture, or I should say the size of your texture is very heavily impacted by the size of your particles. So we may need to come back and start to increase this scale if we need to introduce a little bit more of the detail back into this density. All right, and there we go. Now, if we were to actually compare what these two look like, just for a little bit of a reminder of what we had to begin with, you can see that what we had before was, again, some of these more intricate patterns as far as a little bit tighter edge on this, and a little bit more variation in the overall silhouette of this smoke pattern. So, like I said, this would be something that is probably a little bit better suited for something that has a little bit more complexity in the shape, a little bit more complexity that may be required in the actual dynamic simulation, something like a thick smoke, maybe even flames, whereas this particular render, the exact same volume cloud, but with larger particle sizes and a much lower particle count, you can see gives us something that is much softer and much more uniform. You can see that we've lost a lot of these individual shapes from the wind texture. By the time this is applied over such a few number of particles with such a large size, really all of that detail is lost. So much more uniform in shape with these really, really soft edges and things like that. So this would be really well suited for maybe a cloud bank, some kind of a nebula, really soft smoky effects. So really just depending on what your particular need is for your particular simulation, that is really going to govern what you should use, whether that be a smaller particle size with a higher particle count, or a fewer number of particles with a much larger particle coverage. Okay, so just a couple things to keep in mind whenever it comes time to actually simulate and then render out your ice particles.